Let us now discuss the next topic, which is one of the last topics in synthesis, which is LEC, that is logical equivalence checking. We will be using the tool LEC, or it's also called Conformal. Uh, and this is an interface to Genus. This is also again by Cadence. If you want to have an overview of this LEC and other related concepts, you can look at this Cadence support. So what is logical equivalence checking? So once we have done the synthesis, we've converted the RTL to a gate level RTL, and we want to find out if this gate level RTL is equivalent to the original RTL in terms of functionality. And that is what the LEC does. So it verifies if the gate level RTL is equivalent to the original RTL in terms of its functionality. Of course, we can also verify it by simulating this and comparing the results with the original RTL. But a tool is going to be more efficient in doing that. So there is a one-step verification and a two-step verification. The recommended is a two-step verification. So what they do is the first level of synthesis, which is converting RTL to intermediate gate level netlist after SynGen is going to be used first. So it first performs the SynGen and of course the syn map, because once you do the syn map, it actually gets mapped to the library cells. So once you do the SynGen and syn map, you get an intermediate set of gates. So that is the first level of comparison that is done. So once you get the RTL after SynGen and syn map, we compare that gate level netlist to the original RTL. So that is what the LEC tool does. That's the first step. The second step is after we do the syn opt. So once we complete the syn opt, there is another gate level netlist which we obtain. So it is now going to compare the gate level netlist generated by the previous step with the syn opt netlist. So this is a two-step process. So we have syngen, syn map, and syn opt. So first, this is the first level. So once we complete the first level, we compare this with the original RTL. And once we complete the synopt, we, we compare this RTL with synopt. So this is a two-step process. This is another simplified verification flow. There is another simplified verification flow, which is just a one-step process. That is basically once you complete the synopt, we just write out all the commands required for LEC and then just compare the final RTL with the original RTL. So this is another flow, but this is a simplified flow. So the commands are shown here, taken from Genus Conformal Legacy UI user guide. So the first thing is to perform SynGen. So before that, we of course read the HDL, elaborate, and perform SynGen. Then perform a SynMap. And then the next thing is to do SynOpt. So after this, we are going to write out some commands to do logical equivalence checking. And there are inbuilt commands to do that, which are called write HDL LEC. So this is going to write out the uh, uh, LEC file required for verification. So this is the uh, .v file, which is going to be used for comparison. So then the actual commands to perform LEC, I repeat, the actual commands to perform LEC are going to be written by write do LEC command. And we should also tell it which are the two designs we want to compare. Actually, when I show the commands, I'll be more clear. So basically, we are telling that there is a golden design, which is the original RTL, and then you have the final design, which is written out uh, by this step, that is write HDL step. So there are basically two RTLs which we are comparing. And all those commands are written out to this RTL to final dot do. So this is a dot do. Usually dot do files are very common. They usually have all the commands to perform the execution. So then we have to run this dot do using LEC. So that is the last step, which I'll be explaining again when I demo the tool. If you do a two-step process, we will be doing this write HDL and write do LEC two times. The first time is when we finish SynMap, and the second time is after we complete SynOpt. There is also what is called as a flat hierarchy. So we can ask LEC to perform either a hierarchical comparison, that is, all the RTL to gate comparisons will be performed in a hierarchical fashion without flattening out the netlist. Now, flattening the netlist means that you flatten out all the modules to just the basic gates. If we do a hierarchical comparison, which it means that we still retain all the modules. So we can either do hierarchical or flat comparison. And if we want to do a flat comparison, we have to specify hyphen flat option when we do the right do LEC. So this is going to affect only the second compare operation, that is after the sin opt step, because the first comparison which we do is already a flattened netlist. So these are just some general recommendations, but I'll not go through it. Uh, then the next steps are about how to run it, and I think it will be better to run it along with the demo. But basically, this is the command we use, LEC. LPXL is used because this is low power. We only have the license for the low power tool, and therefore we have to specify LPXL. We run it without the GUI, therefore it's called no GUI. Hyphen 64 is just the number of parallel threads we want to run. We can exclude this as well if not required. Then we provide the do file as the input to the LEC. So finally, after we run all of these commands, we also want to view the comparison reports. So to view the comparison reports, we set the GUI on. So basically, this is a standalone tool. This is not to be executed from the genus command prompt. So when you are inside genus command prompt, you only provide commands related to genus. So while you're running LEC, you have to exit genus. Please remember, you have to exit genus. Do not hit Control X or Control Z or Control C, because we will be holding up the license. We always hit exit the genus command prompt, then type in this LEC command. So we are going to get inside the LEC command prompt, and then from here we perform the GUI option. When we do the GUI option, we are going to get this GUI, and there is this mapping manager here. When we run this mapping manager, it is on the left hand side going to show us the golden netlist, that is the original netlist, and then on the right hand side it's going to show us the revised or the flattened or the synthesized netlist. Then in the next window, once we hit that mapping manager, it is going to show this first window as empty, which means it is a set of unmapped points. Unmapped points means, is there any point or net in the golden netlist which is not mapped in the synthesized netlist. So the left hand side is always golden netlist, which is the original RTL that you provided. The right hand side is the synthesized netlist, and therefore we always expect this first column to be empty. So if it is not empty, it means that there is some issue with synthesis and there are some nets which have not got mapped. The next one is mapped points, which means all of these, for example, reset has got mapped to reset here. There is a data in which has got mapped to data in, and so on. So it has to show exactly the same mapped points. Then it will also show the compared points, which are equivalent, which means that the points on the left hand side or the nets on the left hand side are equivalent to the nets on the right hand side. So what we expect is that the unmapped points are always empty. So this is all there is in LEC. We've compared the two netlists, and if we get empty as the unmapped points, no unmapped points, it means that we've passed LEC. So if we want to do the two-step verification, we can of course write out the first lec.do file, run that first .do, and then repeat the same steps for the second .do file. There might be some errors if you're running larger files. It might tell that there are some non-equivalent points. It means that there are some issues with the names of the pins. So you have to watch out if there are any non-equivalent points. If the tool aborts, it means that it is not able to verify equivalence. Again, it means there is some issue either with the synthesis or with the netlist that we have provided. Let me now demo the tool. So we have this LEC two-step dot tickle. The file is exactly similar to what we had earlier with a few changes. The first one is if we are going to repetitively run the tool, I've explained this before as well. We will do remove designs so that you do not get an error. The rest of the process is the same. We have added the write HTL and the write do LEC commands here. So we are going to compare the original RTL that we have with the revised design, which is the synthesized design fvmap.v. We do not have to provide what is the golden RTL because it already knows it. The golden RTL is always the original RTL that we provided as part of the read HTL. So you do not have to specify it again. So we always specify only what is the revised design or the synthesized design. So we've written out the first .do file. Then the next one is the second one, which is again we write out the final .v. The final .v is going to be now the revised design, and the golden design is actually going to be the previous one that we wrote, which is fvmap.v. This is any random name that you can give. This is just fv stands for functional verification. So we are now comparing this fvmap.v to the final .v. So it is just good enough if we run this final .do file. We do not have to run this original one. If you want, you can run it, but then we are anyway going to do that here by this single command. So I'm going to only run the final one. Then what are the commands we need to follow or commands that we need to run after this? I have mentioned it here. So one of the things that we need to be careful is let us first source this tickle file, then I can demo it appropriately. So I have done the source CSHRC hub and I'm inside the synthesis folder. I'm going to now start Genus. So first thing is we have to start Genus and run the script from inside Genus. Then we have to make a few changes to this .do file because we want to later run this in the GUI mode. We have to clear the exit command at the end of it. So let me demo that. So we are inside this genus command prompt. I'll source the entire article file at one go. So it says that there are no designs and therefore there is nothing to remove. So I'll comment out the remove and run it again. So it has completed execution and it has written out the .do file. Now let me open the .do. Now this is the .do file. It has a few commands. We don't have to go through it, but it has a few commands to do the comparison and verification of these designs. It elaborates the design, the two designs, the golden and the revised, and then it flattens the model, compares the points, and reports the points. So there is an exit at the end of it. Let us just remove the exit. You can also comment it out here. So let us remove the exit here. So the next thing to do is to run this .do file, and this has to be run from the LEC command prompt, not the genus command prompt. So we are going to exit from genus using the exit command, and then we will run the LEC command here, which is provided here. So I'm going to just type in that here and wait for LEC to open. So it has now run the commands and it has also opened the command prompt for LEC. Let us now turn the GUI on. It's going to take a while and open up the GUI. On the left hand side, it is showing the golden netlist and the cells. On the right hand side, it's showing the final uh, revised or synthesized netlist. Now, this is a mapping manager which we are going to click on, and it is showing the unmapped points, which is empty, which means all of the points have got mapped. It's showing here the mapped points, and it's at the bottom, it's showing the compared points. Now, there are a lot of options here for you to view. You can view these in the schematics, you can view this in the code, and if there is an issue, you can also diagnose it and so on. You can also hit this option, which is report compared point summary. So it is going to report that in this window, and it's going to show how many of these were primary outputs, PO is primary output, and how many of them were DFFs in the original one and the final one. So you can view a lot of options here, but the key option for us is to view the unmapped points, and we see that there are no unmapped points, and that is really good for us to know. So one of the ways to diagnose the issues is if you click on any of these primary outputs and click on schematics, it's going to open up both the original and the revised netlist. And here, because both of them are same, we get the same netlist. But otherwise, this is another way in which you can figure out issues with the design. So this is the demo of this LEC tool. It's really simple, and it can be done really very easily. There are also other options here which you can explore. You can right click on it and view the schematics of it, expand instance, collapse instance, and view all the original modules and so on. But the primary objective is to view the mapping manager and view the unmapped points.